Okay, so inscribed angles not only have their vertex on the circle, they both have their vertex on the circle here, so they look like they're both inscribed, but an inscribed angle has to be made up of chords. And the first one I drew here is made up of two chords. What is this made up of? A chord and a tangent. Okay, new words for chapter 12. AB is a chord, BC would be part of a tangent. It's a tangent ray. It's part of a tangent. So it's not made up of two chords. It does have its vertex on the circle, and we're going to learn today that it also has the same characteristic as an inscribed angle, but it's not called an inscribed angle. So be really careful if you have a question that asks you, is this an inscribed angle? It would not be. This is an inscribed angle because it has its vertex on the circle and it's made up of chords. Okay? When you have an inscribed angle, it creates what we call an intercepted arc. And that is just the arc that is inside the angle. So this right here would be your intercepted arc. Okay? Intercepted arc. And I'll put some letters there like A, B, and this is D. All right, and then this word subtends. I'm not going to have you use it a lot, but they use it sometimes in the directions. And if you don't understand what it means, it'll make it confusing when you're reading the directions. So basically what it's going to tell you here is a chord or an arc will subtend an angle if its endpoints are on the angle. What that means is when I look at this picture, they may say arc AB subtends angle ADB. That just means arc AB has its endpoints on the angle. Or they may say chord AB subtends the angle. That just means it has its endpoints on the angle. Does that make sense? So when you see that word subtends, just think that means it has its points on the angle. Or it's inside the angle, if that helps. All right, so first theorem that we're going to learn today is what's true about the inscribed angle and its arc. We already said that the measure of the central angle is equal to the measure of the arc. But what we're learning new today is the measure of an inscribed angle, so the measure of angle ADB, it is not going to be equal to the measure of the arc. It is going to be equal to half the measure of the arc. Half. So it will equal half of the measure of arc AB. And the way I remember it is if the vertex is on, that you're supposed to have your 12-4 notes that I handed out last class period, and I asked a few minutes ago if anybody in here did not have their 12-4 notes. Caleb raised his hand and I handed them out. One more time. Anybody not have their 12-4 notes from last class period? You need to be with me right now and have your notes so you can fill them in. Okay. Are we good? Everybody here? The way I remember it is if the vertex is on the circle, it's half the arc. If the vertex is at the center, it's equal to the arc. So that's the first theorem today. We're going to skip examples, so if you're looking at your notes, you can jump ahead. And we're going to go to this next theorem. It is not really any different than this theorem. So again, if you're making a theorem sheet, we're going to number this number 9, but it is basically just saying this exact same thing, but adding one more thing you might notice when you look at it. So that's kind of wordy up there. If you look up here on the board, I'll try to explain it a little easier. So they're going to say if you have a circle and you have an inscribed angle and you have another inscribed angle. Would you guys agree that angles A and D both have their vertex on the circle? Are you with me? Okay, and I'm going to label this BAC and BDC. So you can see those two angles. But we all agree these are inscribed, right? Okay, their vertex are on the circle. What arc does BAC subtend? What is its intercepted arc? BC. And what arc does BDC subtend? What is its intercepted arc? Say it again. not CD. We're looking at this angle BDC. What is its intercepted arc? Also BC. Remember, intercepted is what's inside the angle. So when I go from here, do we agree this is inside the angle? And when I go from B to A to C, this is also inside the angle? And what did we say the measure of this angle is compared to the arc? 1/2. The angle is half the arc if it's on the circle. So if angle A is half of BC and angle D is half of BC, then what does that mean has to be true about angles A and D? They're congruent. And that's what this theorem is going to say. It just says if they have the same intercepted arc, then they're going to have the same measure because they're all going to be half of that arc. Does that make sense? So when you look up here, do you guys notice that angles C, D, and E all intercept arc AB? And so all three of those angles would be congruent. Remember, intercepted arc is the arc that's inside the angle. Okay? All right, we're going to skip that one. Move ahead. Go to this next one. Third theorem today. So number 10. This one's going to say almost the exact same thing again. It's going right back to the same theorem. If the vertex is on the circle, the angle is half the arc. Okay, so here's what they're saying in this one. If you have a circle and your inscribed angle has its endpoints on the diameter, would you agree here that AD is the diameter? Okay. If this is the diameter, what does that make the measure of arc AD? 180. Does everybody agree it's a semicircle? It's half the circle, it's 180? So if we use this theorem and the vertex is on the circle, then the angle should be half the arc. What should angle E be up here if it is half of this arc? 90. So that means this should be a right angle. That's what this theorem is saying. It's just saying that if you have an inscribed angle and you notice that it has its endpoints on the diameter, then that means it's going to be half of 180, so it's going to have to be a 90-degree angle. It's really not any different than just using this. You just have to notice that it's 180 degrees because it's a semicircle. Is that okay? Questions? Okay, last part for 12.4, number 11. Skip ahead in your notes. There's one more theorem, and this one's different than the rest. It doesn't really relate to these three. These three are all very similar. They're just basically going back to the angles half the arc. So if they have the same intercepted arc, they're going to be congruent. The angles half the arc. So if it's a semicircle, that makes it 90. This is different. Last one for 12.4. If you have a circle, the only way that you can inscribe a quadrilateral, inscribe, what does it mean to inscribe? Okay, put it inside the circle so that its vertices touch the circle. So the only way that you can inscribe a quadrilateral in a circle is if the opposite angles are supplementary. What's it mean to be supplementary again? Add to be 180. So if I look at my quadrilateral here, A, B, C, D, which angles would have to add to be 180? AC and BD. So the measure of angle A plus the measure of angle C has to equal 180, and the measure of angle B plus the measure of angle D has to equal 180. And that's the only way a quadrilateral can be inscribed in a circle is if its opposite angles are supplementary. Think about some of the quadrilaterals we know right now. Can you think of two quadrilaterals that guaranteed every time would have opposite angles supplementary? A square and a rectangle. Because what are the measures of the square and rectangles? Angles. 90. And 90 plus 90 is 180. They're not the only ones though. You could maybe have a 30-degree angle and a 150-degree angle. You can just have a regular quadrilateral. It doesn't have to be a special one, as long as its opposite angles are supplementary. Okay? That's 12.4 in a nutshell, those 4 theorems. So now we're going to look at some examples and see if we can work them, okay? So go back to the beginning of your notes. We'll work most of them. We may skip a couple, and then we'll go to 12.5. Okay, so this first example, what do they want us to find the measure of? Angle PRU. So going back to chapter 1, angle from P to R, oops, not S. Let's go back. Oops. PRU. PRU. So we're looking for this angle right here, right? What kind of angle is it? Inscribed. And how do we know it's inscribed? The vertex is on the circle. So the vertex is on the circle, it's inscribed. Today we learned that that angle should equal what? Half of the arc that it creates. It's intercepted arc. So from endpoint to endpoint, that arc is how much? 118. So it should be half of 118. What's half of 118? And don't forget that it should be measured in degrees. Not hard. They get a little harder sometimes just because they may ask you to find, you may have to find an arc before you can answer the question, but the basic idea is pretty easy. It's just half the arc. So if you look at the next one, they're going to go the other direction. This time they want you to find the arc. Which arc? SP. How do we know what direction to go from S to P? Shortest, because they use 2 letters, which makes it a minor arc. So we're looking for this arc here in blue, or now red, SP. So if the angle is half of the arc, what is the arc then compared to the angle? 2 times, twice as much. So the arc should be 2 times 27 degrees, which is 54. Don't forget your degree symbol. Also, don't forget to put those little M's in front of your arcs when you're giving me the measure of the arc, just like an angle. Questions so far? Okay, moving on. So we already talked about this example. We're going to skip this one, by the way. This one's pretty crazy. So you can just not worry about it. And let's go to this example. Okay, they want us to find A. What do you think we could do here to figure out A? Say it again, I'm sorry. Exactly. So Hannah said 5A plus 20 equals 90. Again, this goes to which theorem are we using over here on the board? 8, 9, 10, or 11? 10. Do you see how this angle, WZY, has its endpoints on the diameter, right? So what does that make this arc WY? 180. It's half of the circle. And what kind of angle is WZY, this angle right here? It's going to be a right angle because it's inscribed, and the rule is it should be half of the arc. So that makes this turn into a right angle. So Hannah's right. We can just set that 5A plus 20 equal to 90 degrees. Questions? Don't really understand where we got that? Okay, subtract the 20. What does that make 5A equal to? 70, and then divide by 5. What do we get for A? 14. And all it did was say find A, so we're done once we find the value of A. Questions on that one? Look at the next example. What theorem on the board are we going to have to use to answer this one? Heard a couple people say 9. So when we're looking at these 2 expressions, what are they referring to in the picture? The angle measures. They're pointing to angle LJM, and the other one is pointing to LKM, right? And what do you notice about their intercepted arc? What arc do they both intercept? LM. If they intercept the same arc, what does that mean about this angle and this angle? They're congruent because they have to be half of the arc since they're inscribed. And if it's the same arc, then that means they're going to be equal to each other. So what would I write down to start trying to solve for B? 5b minus 7 equals 3b. Okay, what do we want to do from there? Okay, subtract 5b, I heard. So now we have negative 7 equals negative 2b. And then now what do we want to do? Divide by negative 2. So what is b equal to? Positive 3.5. The question didn't say find b, though. What did it say to find? Angle LJM. So we're going to substitute that 3.5 in for b. So now we have 5 times 3.5 minus 7. What do we get for the measure of angle LJM? 10.5? Somebody agree? Okay. 10.5 what? Degrees. Any questions on that one? All right, look at the next one. And I believe this is the last one in 12.4. Is that correct? All right. Go ahead and see if you and your partners can work this last example. Using which theorem on the board are you going to have to use? 11. So go ahead and see if you can answer it. Notice it says find the angle measures. How many angle measures are there in this quadrilateral? 4. So you're going to find all 4. Go ahead, you and your partner, and then we're going to come back together if you're not quite finished. As you're finishing, look back up here. Just be super careful on this. Remember that the theorem doesn't say that the angles are equal, and it doesn't say the consecutive ones are supplementary. It says what? Opposite angles are supplementary. So B and D add to be 180, A and C add to be 180. So over here in our picture, that means J and G would add to be 180, or K and H would add to be 180. But we can't do K and H because we don't know what H is. So we're going to use the 6B plus 20 plus 3B plus 25 and set that equal to 180. Also, one little minor algebra mistake that I see just every now and then, not a lot, is sometimes students don't combine like terms correctly on the same side of the equation. So remember, if they're on the same side, you're just combining them. 6 plus 3 is 9b, and then 20 plus 25 is 45. You don't use opposite operations unless you're moving from one side of the equation to the other side of the equation. So now we would subtract 45. 9b equals 135, and so b was equal to 15. Once you found b, you had to go back and plug it in. So you found the measure of angle J was equal to, what is 6 times 15 plus 20? 110 degrees. So picky little notation. Make sure you put the little m. Make sure you put the degree symbol. You could plug 15 in for G, or you know that G and J have to add to be 180. So what does the measure of angle G have to be? 70 degrees. So that's a little faster just to do it that way. K, we can plug in that 15. So what is 10 times 15 minus 69? 81 degrees. And then how did you find H? Same idea as what we did to find G. If this angle and this angle have to add to be 180, 180 minus 81 is 99 degrees. Questions anywhere on 12.4? Would you agree it's pretty easy? Just be real careful that you memorize those theorems. I can't warn you enough. The hardest part for chapter 12 is when we get to the test, remembering all these little rules. Okay, that's the hard part. But once you know the rules, the math becomes pretty easy. All right, we're going to shift to 12.5 now. It's also not difficult as far as the big ideas go. And we're going to skip the warm-up. So if you'll just jump straight to your 12-5 notes. Anybody not get the 12-5 notes before we get started? Okay, so I'm going to do the same thing. If you're making a theorem sheet, we're going to go ahead and go through all the theorems first, and then we'll go back and work the problems, okay? So we ended on number 11, so this will be number 12. This theorem is not any different than number 8. It is exactly the same. The only difference is the number 8 theorem said it was for inscribed angles. This picture shows this angle. Is this technically an inscribed angle? No, what's wrong with it? The sides of the angle are not what? Not both chords. One of them could contain a chord, but the other one is a, what is this? BC. It's a tangent, okay? It's a tangent. So it's a tangent and a chord. But where is the vertex of angle B? Is it at the center? Is it on the circle? Where's the vertex of vertex B? On the circle. So the way I remember the rules is not based off the names of the angles, but I remember the rules based off the location of the vertice or the vertex. Where are the vertices? Where is the vertex? If the vertex is on the circle, then the angle equals the arc. If the vertex is, on the center, not on, try again, Lashley. If your vertex is at the center of the circle, then the angle equals the arc. If your vertex is on the circle, then the angle is equal to half the arc. And it doesn't matter if it's an inscribed angle or not an inscribed angle. As long as your vertex is on the circle, the angle is half the arc. Okay? So number 12 really isn't any different than number 11. It is still, you have an angle whose vertex is on the circle. If the angle has its vertex on the circle, then the measure of the angle is equal to half the measure of the arc. Be careful here, the arc would be arc A, and it would go all the way around to where? B. Okay, that whole arc. So it would be half the measure of arc AB. But it's still the same theorem. Does that make sense? Okay, so 12.5 is basically just about angle measures. 12.5 is going to say there are 4 kinds of angle measures you're going to see. Number 1 is the one we already learned prior to today. Central angle and arc are equal. Second angle is an inscribed angle or an angle who has its vertex on the circle. The angle is half the arc. The next 2 are going to be different angles, and that's the end of 12.5. So I'm going to fast forward to the next 2. So there's just 4 kinds of angles in 12.5. The first one we'd already learned, the inscribed angle we had already learned, and then these 2. So this is where we figure out what do we do when the angle is inside the circle but not at the center. So number 13 theorem. If you have a circle and you have an angle formed inside the circle, but it is not at the center. Everybody with me? So we're looking at maybe angle ABC here. Or it could be DBE, or DBA, or EBC. Any of these 4 angles are inside the circle, but they're not at the center. I'm going to use a different letter here. Let's call this O. Are we all with me where we're at? What the idea is? Okay, here is the theorem or the rule. If your angle is inside the circle, not at the center, then the measure of the angle, I'm going to call this one ABC, will be equal to, it's still half, but now you're going to add the 2 arcs that are created by the angle. And there are 2 arcs that we're going to talk about. The one the angle makes which would be arc AC. You guys see that angle and that arc? And then I'm going to call it its vertical arc, even though they're not congruent arcs. But arc AC and the arc across from it, DE. This theorem says you add the two arcs together and take a half. So it is half of the measure of arc AC plus the measure of arc DE. So if the angles are inside, that's how I remember it, at the center, on the circle, or inside the circle, here's your rule. Add the two arcs and take a half. Everybody with me? So if I were looking at this bigger angle, EBC, then I would add its arc. What arc does this angle make? EC, which would be from here all the way around to here. And what would be the arc across from it? DA. Marker's not very good. Are you guys with me? So if the angle is inside the circle, find the arc that it intercepts, and then find the arc that's across from it. Add them together, take a half. Last theorem for today is what happens when the angles are outside the circle. So they're not at the center, they're not on the circle, they're not inside the circle, but they're outside the circle. So number 14. If you have a circle and the angle formed is outside the circle, I'm going to call this angle 1. Okay, if the angle is outside the circle, notice there's 3 different pictures here because it doesn't matter what makes the angle. What would I call this CD in terms of the words we've learned in chapter 12? Tangent. What would I call CA? It's part of a what? But what do we call it? Every line has a special name in chapter 12. What do we call a line that touches a circle twice and goes through the circle? Secant. So this is made up of part of a secant and part of a tangent, right? This is made up of 2 what? Tangents. And this is made up of 2 secants. And what they're trying to show you is it doesn't matter whether it's secants, tangents, chords. If the angle occurs outside the circle, then here is the rule that you're going to use. It is very similar to if it's inside the circle. If it's inside, you add the 2 arcs and take a half. What do you think you do if it's outside the circle? Subtract the 2 arcs. So if it is outside the circle, then you're going to subtract the 2 arcs. You've got to find the 2 arcs first. So make sure you're subtracting the correct 2 arcs. So if I'm looking at angle 1, you need to do bigger arc minus smaller arc so that you get a positive number. Don't do it the other way around or you'll get a negative number. You're looking for the arcs that are inside the angle. So what's the bigger arc that's inside this angle 1? DF. That's its intercepted arc. And then what's the arc that would be across from it that's still inside the angle? BE. So the rule here would be the measure of angle 1 would equal half. It's still half. It's going to be half every time unless it's a central angle. Central angle equals the arc. Everything else is a half. Either half the arc if it's inscribed, half the sum if it's inside, or half the difference if it's outside. So it's going to be half of the bigger one, the measure of DF, arc, minus the measure of arc BE. Okay, and so there's just 4 rules for angles. If it's at the center, they're equal to the arc. On the circle, half the arc. Inside, add them and take a half. Outside, subtract them and take a half. Let's practice. Any questions before we work some examples? All right. Let's go back to the beginning. So look at the picture. Find angle EFH. First thing I want you to ask yourself is, where is the vertex for EFH? Center, on, inside, or outside? On. What's the rule if the vertex is on the circle? It's half the arc. So the measure of this angle should equal half the measure of the arc. Okay, so then we have to decide what is the measure of the arc that that angle creates. 130. It's creating arc FH. So it's going to be half of 130 degrees. What's half of 130? 65, and don't forget your degree symbol. Again, the only thing that makes this harder on the homework, maybe they don't give you the arc and you have to find it. So maybe they give you some of the other arcs and you have to add them together and subtract it from 360 for a full circle or something like that. But the big idea is just if it's on the circle, it's half the arc. Questions here? Okay, look at the next one. What do they want us to find this time? Measure of the arc, GF. Okay, so now we've got to figure out what is a relationship between GF and something else in the picture. So we learned that if the arc is formed by an angle that's on the circle, the angle is half the arc. Do you see an angle that is forming GF? Is there an angle in the picture that creates arc GF? Okay, FHG is not really drawn. You'd have to have a line that goes here if we're talking about an angle, right? What angle makes that arc, FG? Say it again. GFE would be this angle. It's going to create this arc all the way around to here, but not the red one that we're looking for. From 360. You sure could. I think that's a harder way to work it, but you sure could do it that way. So what's making that red arc is the angle FG, and then they don't have a letter, so it's hard to name it, right? But do you see how that angle is creating this arc? Is everybody with me? This angle, F, G, and then this arrow. I can put a letter here just so we can name it. I'll call it C. FGC is making this arc FG. Is FGC's vertex on the circle? So the relationship is the angle should equal half the arc, right? Do we know the angle, though? No. But we do know, back in one of our early chapters that we talked about, if two angles are side by side and they form a straight line, they're supplementary. So if this angle is 122, what could we do to find this missing angle? Subtract it from 180. So 180 minus 122 gives us 58 degrees. So now we know this angle that's creating that arc is 58 degrees. So if the angle is 58 degrees and it equals half of the arc, what do we need to do to find the arc? Multiply it by 2. We need to get rid of the 1/2 by multiplying both sides by 2. So the arc would equal twice the angle. So the measure of arc GF would equal how much? 116, and what are the units? Degrees. Okay, they get a little harder like that, where you have to think about what do I know in my picture. But that is correct. We could have used this 122 degree angle to find this whole arc. Let's talk about that real quick. Notice the 122 degree angle makes this whole blue arc. So what would be the measure of the blue arc? If the angle is half the arc and the angle is 122 degrees, what would that make this whole big arc? 244 degrees. which means the rest of it, the red angle, should be how much? 116. 360 minus 244. And I don't know that that was any harder. That probably was a little easier even. Everybody with that there? Okay, so either way, we still get 116 degrees. Okay, look at the next one. What does it want us to find? Angle AEB. Where is the vertex for angle AEB? Inside. It does not show to be at the center, and it doesn't look to be at the center, so it's not the same as the arc. We learned that if it's inside, what do we do? Add the two arcs and take a half. So I usually write down on my paper the angle should equal half of arc plus arc. Just to get the general idea. I'm going to add two arcs and take a half to find my angle. Okay, now I have to figure out which two arcs to add. Remember, it's the one that's inside the angle. So what arc is inside the angle? 139, AB 139. And what other arc do we add to it? The one across from it. You can think about it like a vertical arc, but know that they're not the same measure. So the one across from it, which is 113. So it is 1/2 of 139 plus 113. You add when they're inside. What do we get when we take half of 139 plus 113? 126. So the measure of angle AEB is 126 degrees. Again, be careful. They may not give you the two arcs you need. You may have to solve for one of them first and then work the problem. So sometimes it's a little bit more tricky. Questions on this one? Okay, look at the next two, A and B. Where do you notice on both of these the angle lands? Outside the circle. So the rule is the angle will equal what? In general, what's our big idea? 1/2. Very good. Arc minus arc, but be sure to do the bigger one minus the smaller one. And it's the two arcs that are inside your angle. So on this first one, I'm looking for the angle here, and it is outside the circle. So what is the bigger arc that's inside that angle? 87. And what's the smaller arc that's inside that circle? 7. And it's kind of hard to tell because I wrote that 7 here, but they're meaning that it is that arc. So it should be 1/2 of 87 minus 7. What's half of 87 minus 7? 40. So the value of x would be 40 degrees. Okay, basically the same idea on part B. Where is the angle located? Outside the circle. So it should be half of arc minus arc. Again, make sure you do bigger minus smaller. So when you look at that angle, what's the arc inside that's the biggest? 200. What's the arc that's inside but is smaller? 74. So it should be half of 200 minus 74. What do we get? The total answer is 63 degrees. Awesome. Questions? All right. They get a little bit harder. That's the big idea. So what I want you and your partner to try, this one is not any different really. It makes it look like it's harder, but it's really not. We'll just talk about it and then we're not going to work it. Where is FH? Arc FH? How do I know if I go F to the right to H or F to the left to H? To the right because it's only 2 letters. So F to H is this whole thing. They're telling you it's 108. And then what is FKH? Careful, it's angle FKH is what you're looking for. And where is that angle? outside the circle, and then they also give you arc LJ. Again, how do I know if I go from L to J to the right or L to J to the left? To the right, because it's just 2 letters. So do you see that they're giving you in this picture the big arc made by this angle and the little arc made by this angle? So it's not any different. It's just 1/2 big arc minus little arc. They make it look harder because you have to add it to the picture, but it's not any harder, okay? So let's skip that one. And I want you guys to look at this problem, okay? And actually, how many problems are left? Are there just 2? This one is, yeah. Okay, I'm going to give you about 5 minutes, and I want you to see if you can figure out the next 2 problems. So this one and the next one. Thank you. Thank you. Okay, so we know this arc should be formed by this angle. Would you guys agree that this arc is formed by this angle? All right. And this angle is located where? Inside, outside, on the circle, or at the center? Inside. So we know this rule right now could be used, that the angle is equal to 1/2 of arc plus arc. But we don't know what this arc is, and we don't know what this arc is. If we knew this little arc that's across from it, UW, then we could plug in the UW arc, we could plug in the 113 for the angle, and we could solve for the missing arc. Would you agree with that? Let me say it again. If we knew this little arc UW, we could plug that in for one of the arcs, the smaller one, and we could put the angle in for the angle, and that would leave us with being able to solve for YZ. But the problem is we don't know this arc. So we will need to find that arc if we're going to use that method. So let's think about some things we do know. If this is 113 degrees, what is this angle right here? Dad? Not 167, 67. And is everybody with that those 2 angles form a straight line, so they're supplementary? So that means this angle right here has to be 67 degrees. And we know this angle then is also 67. And I'm just kind of talking through some things to see if I can figure out what I need to know. So I know this is 67, this is 67. What do I know this angle is right here? 113. So I'm just figuring out things in my picture. If I don't know what to do, that's the best way to work the problem, is just start finding things you do know. So let's look at this angle that's 67 right here. I'm going to use a different color. See if this will help us. Look at this angle right here. I know this is 67. I know it forms this arc, which is 68. So could I find this missing arc right here? Because what do we know about this angle since it's inside the circle? The angle should equal 1/2 of the arc plus the arc, right? And we know the angle, and we know one of the arcs, so we should be able to find the missing arc. So let's see if that helps. Let's plug that in. I'm not sure if it will, but let's try it. So we have angle equals 1/2 arc plus arc. The angle we're looking at right now is in red. What was the measure of the angle in red? 67. That equals 1/2 of, what is one arc that it creates? 68 degrees. And the other arc that's across from it is named what letters? UY. So we're looking for the measure of UY. And again, I'm just trying to think through what could we maybe find here to work our way to the answer, which is what is YZ. Okay, so now let's work backwards to solve for UY. What would we need to do to start getting UY by itself? We could distribute the 1/2. If we do that, we're going to have to distribute it to both. What might be easier than distributing the 1/2? Just go ahead and divide by 1/2 and move it to the other side. And what's the same thing as dividing by 1/2? Multiplying by 2. So either way you want to look at it, you can either divide by 1/2, or multiply by 2. Just be careful, you're not taking 67 and dividing it by 2. You're taking 67 and dividing it by a half or multiplying it by 2. So you end up with what over here on the left? 134 equals 68 plus the measure of uy. Now what could we do? Subtract 68. So what's the measure of that arc? 66. Everybody agree? Okay, so back up here in my picture, I now know that this arc is 66 degrees. I'm still trying to find YZ. So now look at what we know. This angle X is where? Inside, outside, or at the center? Outside. So if we look at that angle, I'm going to use a different color. See if you see it now. This angle creates arc what? YZ, which is what we're looking for also, right? So instead of using what I thought about first in blue, what if we use this angle outside the circle? Notice it creates YZ because now we know this angle in green. And what's the other arc that it creates, the smaller arc? 66, the one we just found. Do you guys see that? So now we're going to use the one outside the circle. So let's use our rule. Angle outside is equal to 1/2 of what? Arc minus arc. Okay? What's the angle that we're looking at? 49. And that should equal 1/2. What's the bigger arc? YZ, we don't know, so we're going to leave it as the measure of YZ, which is what we're trying to find. Minus, what's the smaller arc? 66, which is what we just found. So do you see how some of these can get a little harder? You've got to find something before you can find something else, and you may have no idea where to start. You just have to start finding things until you see a relationship. Okay, again, we have to work backwards. If you want to distribute the 1/2, you're welcome to. Just make sure you do it to both. Otherwise, I think it's easier to get rid of the 1/2. Just go ahead and divide both sides by a half or multiply by 2. So what's 49 divided by a half? What is it? 98. And that is equal to the measure of arc YZ minus 66. So now we're going to add 66. No, we decided to divide by a half to get rid of the half, so the halves canceled out. So there's not a half left over here. Okay? Or when you multiply both sides by 2, the 2 and the 1/2 cancel out. So you're not really distributing the 2. Okay? Add 66. So what's the measure of arc YZ? 164 degrees. Okay, that's harder. It could get that difficult, so you're going to have to really make yourself persevere and just start finding things until you figure it out. Okay? One last example, if you would, real quick, write down on your paper is right here. This will show up on your homework and on your test. It is not in the notes. So take a minute and draw this picture on the back of your notes or somewhere where you have room. If you're not here and you're watching the video, make sure that you get with someone from your class period or come in and see me so you can get this example. Okay, are you guys ready? We want to find x. What relationship do you see in this picture from today that might be helpful? So looking at that side of the board, do we have an angle vertex on the circle, inside the circle, or outside the circle that might help us? Outside. So again, when I'm writing this down, I would probably just write angle equals 1/2 and then use our relationship. Outside is arc what? Minus arc. So I kind of just start there and then start filling in the pieces that I know and look for the pieces that I don't know. So we're looking at this angle that's outside the circle. What is that measurement going to go in for the angle here? 42 equals 1/2 of. Now, this arc AC is inside the angle and we're calling it X. That's the smaller one. Then the other arc goes all the way around the rest of the circle. How did you find the measure of that missing arc on the last example that you worked on by yourselves? If you knew this value, how did you find the rest of it? Subtracted it from 360. So same idea here. We don't know this number, but we could still call the rest of this arc 360 minus X. You guys with me? The rest of that arc from A all the way to C would be 360 minus X. So if this was 30, you would have done 360 minus 30. We just don't know what it is, so we're going to put 360 minus X. Okay, and now we're going to plug those two things into our formula here. So which one of them is bigger and needs to be written first? 360 minus X. And then the formula says minus, and then we're going to plug in the other arc, which is X. You guys with me there? So it's half of the bigger arc we don't know. It's 360 minus whatever this is. So we'll say 360 minus X. Minus, and then the littler arc, which is X. Now use your algebra skills. Simplify the right-hand side here. So we have 42 equals 1/2 of. What is 360 minus X minus X? 360 minus 2X. Are you guys with Haley? Minus X is just minus 2X. That's like negative 1X and negative 1X, which is negative 2X. Okay. And now we just need to solve. Again, you can distribute the 1/2 if you prefer. Just make sure you distribute it to both. Otherwise, what have we been doing on every other problem so far? We've been multiplying by 2 or dividing by 1/2. So raise your hand if you would rather distribute the 1/2. Okay, then I'm not going to work it that way. I'm just going to divide both sides by 1/2 or multiply by 2. Those are going to cancel. What is 42 divided by 1/2? 84, because you're multiplying by 2. And that's going to equal 360 minus 2X. What do we do from there? Subtract 360. So now we end up with negative what? 276. So negative 276 equals negative 2X. And then what do we do? Divide by negative 2. And so what is X? 138. Everybody agree? And that would be degrees because it's an arc measure. Questions on that one? Okay, so making sure we're clear what we're doing for homework. Assignment number 20, the one you already have, is due when? Friday. And you're finishing it up and it's over the 12-4 section, not this section. Then this assignment that I just gave you, the first page, 834, is over this stuff. So you should be able to do all of page 834, but you have not learned how to do page 843. So this blue assignment today, number 21, is due when? Tuesday. You may want to write on there due Tuesday so you don't get confused, okay? But again, I encourage you, go ahead and do the first textbook page so that on Tuesday you're not so overwhelmed when you get another slip, because that's going to be a lot to try to keep up with, okay? Any questions? All right, if you need my help,